Welcome again. Now let's give a solution to problem 4. So which says, which of the following relations relations are functions from set A to set B, and then write down their domain and range. Now, there are 3 parts. So part A, we were given the relation 1, minus 2, 3, 7, 4, minus 6, and then we have 8, 1. And then we have been told that the set A, this is set with elements 1, 3, 4, 8, and set B has elements minus 2, 7, minus 6, 1, and 2. Now, the first thing is that a relation is simply a set with ordered pairs. And for a relation to be a function, then you have to check if there are if that in all the pairs given, there is no 2 distinct pairs which have the same first element with different second element. So this is what I mean. So you can draw a sketch to illustrate this to be able just to answer the question properly. So I can say, let this be my set A, and let this to be my set B. And then we have been told that the elements in A are 1, 3, 4, and 8, while in B, we have minus 2, 7, minus 6, 1, 2. Now, what the given relation means, in this case, 1, minus 2 means that the value 1 from A is mapped to minus 2. 3, 7 means 3 is mapped to 7 in B. 4 minus 6 means 4 is mapped to minus 6. 8, 1 means 8 is mapped to 1. Now, since there is no pair or there is no element from this set A that has 2 arrows from itself going to different elements in this set B, then this given relation is a function, because there are no 2 values in B having the same value from this first set. So therefore, you say the given relation is a function since no 2 distinct pairs have the same first element and different second elements. So that is what we say, that the given relation is a function because there is no two distinct pairs such that the first element has different values of the second element. And then remember, the domain is given by the set of all this, the first elements given in the relation. So we have 1, 3, 4, and then 8. And for the range is the set of all the outputs or the set of all the second elements in the relation. So we have -2, 1, 7, -2, 7, and then we have -6, and then 1. Remember, 2 is not in the range because there is no element from A which is mapped to 2. So you don't include 2 in this solution here. So this is the range, the set of all the second inputs in any given relation. And then part B, we had the relation 1, 0, and then we have 1, -1, and then we have 2, 3, and then we have 4, 10. And then set A has 1, 2, and 4, and set B has 0, -1, 3, 10. So what you do, you try to sketch these two sets A and B. A, and then this set B. So set A has elements 1, 2, 1, 2, and 4. This other one has 0, -1, 3, 10. Now let's see. 1, 0 means 1 is mapped to 0. So this is what we have. 1 -1 mean 1 -1 means 1 is mapped to -1. 2, 3 means 2 is mapped to 3. And 4, 10 means 4 is mapped to 10. Now you see, in this case, 1 from set A is being mapped to 2 different elements, 0 and -1. So when you have such a case, then that relation cannot define a function. So we say the given relation does not define a function since distinct ordered pairs then we have 1, 0, and 1, -1 have the same first element, but different second element. So that's the reason. And then domain for this set is a set of this first element in set A. So 1, 2, 4, while the range is a set of all the second elements in every pair, 0, -1, 3, and then 10. And then part C, we have the relation A, B, and then BC, and then we have CB, and then we have DC, and then our set A is this set with elements A, B, C, D, and E, and B, the set having only elements B and C. So let's draw the sketch for this, and we should be able to conclude from the sketch whether the given relation is a function or not. So this set A, this set B. Now we have A has A, B, C, D, and E. This other one has just B and C. Now, when you say A, B, means A is mapped to B. BC means B is mapped to C. CB means C is mapped to B. DC means D is mapped to C. And since there is no two arrows from these elements in set A, then this relation is a function. So we say the given relation is a function since no two distinct pairs have the same first element and different second elements. So that's the reason. So remember, what matters is the domain of the function, not the final output. So how the arrows are moving from the set A to set B. And so the domain for this case is a set having elements A, B, C, and D. Remember, you don't include E because E is not, so this also, you don't include E because E is not being mapped to any of the elements in set B. Remember, the definition of domain in any given relation is a set of all the first elements in every pair. So A, B, C, and D are the first elements in these pairs. So E is not part of this set. And then range is simply B and C, the set of all those second elements. You see B, C, B, C. So you don't have to repeat writing B, C, B, C, just write once B and then C. So that is what that question was supposed to be, and that's the solution. The next session will do problem 5. Thank you.